Okay, here we have question number 12 from May-June 2015, paper 2, variant 3. Question about speed time graphs. A car starts from rest. Zero starts at 0 seconds, rest 0 meters per second. Okay, here meters per second. Here we have meters per second. Meters per second, here we have seconds. So units are compatible. And accelerates for u seconds. Okay, so there's a number of seconds which they've called u accelerates, constant acceleration. Okay, you can see it's constant, straight line. Okay, until it reaches speed of 10 meters per second. It then travels for 10 meters per second for 2u seconds. So a further 2u seconds, so it ends up at being 3u seconds. Okay, it's now traveled, okay, that 2u, 10 meters per second for another 2u seconds. So it's been traveling altogether for 3u seconds in this graph. The distance traveled by the car in the first 3u seconds is 125 meters. Find the value of u. Okay, so we know that the area under the curve, under the graph, tells you the distance traveled in a speed time graph. So a speed time graph, how do you link the distance traveled, okay, in a speed time graph? You do that by the area under the graph. So I know if I find the area of this shape, which is a trapezium, it should equal 125 meters. Okay, so the area, okay, under the graph should be 125 meters. Come on, pen. Okay, so it should be 125 meters when I do the area under this. Now this shape here is a trapezium. It's a trapezium shape. To find the area of the trapezium, there's different ways people do it. One of the ways is to kind of split it into a triangle and a rectangle. Okay, I personally prefer to use the area of a trapezium, which is given in one way normally, but I like to think of it as the distance between the parallel sides, which I call the height of the trapezium. Sometimes it can be, height can be horizontal if the parallel sides are going up. In this case, the parallel sides are the vertical line, the time axis, and this line going through 10 on the top. Okay, so it's the height is the distance between the parallel sides divided by 2 times, and I put a plus b, the sum of the parallel sides. So the area of this is going to give me by the distance between the parallel sides, which is 10, divided by 2 times the sum of the parallel sides. Well, the distance from there to the end is 2u. And the distance from 0 to there is 3u. So you're going to have 2u plus 3u. Okay, so the area is going to be 5 times 2u plus 3u. Okay, so I have 5 times, sorry, make that easy for us. 5 times, because they cancel, 2u plus 3u is 5u. 5 times 5u, which is 25u. Let me put that multiplication sign properly there. Okay, so that's the area under this. That should be equal to 125. So we can say that 25u must be the same as 125. So u is going to be 125 divided by 25, which is 5. 5 times 20 is 100. 5 times 5 is 25. So 5, the value of u is 5. So that's 5 seconds. That would be 5 seconds, and that would be 15 seconds. 3 times 5. Okay, so the value of u is 5. That's what we had to find. U equals 5. Then it says find the acceleration in the first u seconds. Well, that's pretty simple. Now we know what u is. The acceleration in the first u seconds means the acceleration in the first 5 seconds, which is the gradient of this line. To find the acceleration from speed time graph, you need to find the gradient of that region where the acceleration here is. Now the acceleration here is a constant acceleration between 0 and 5. So if I take the beginning and the end, which is 0, 0, and this is 5, 10, and I find the gradient of this line, it's 10 minus 0 over 5 minus 0. So the acceleration is going to be 10 minus 0 over 5 minus 0, which is 2 meters per second squared. That is the acceleration. That's the gradient of this line, which is the acceleration. And there we have this question answered.